Good morning, student. Thank you for following up the channel and the lectures, and hopefully we will have a good semester through the internet videos, and of course we will have also an online channel during our university website. So follow up the videos. As you remember, we stopped at how to solve non-homogeneous second order differential equations. So as you remember, it was a y double prime plus b y prime plus cy is equal to 0, because there is no action but there is initial condition. So suppose that I want to solve the following equation: y double prime minus 9y is equal to 0. This is a second order equation with a is equal to 1, b is equal to 0, and with c is equal to minus 9. So in the beginning I want to show you you can solve this equation using the guess by guess. So if you say y double prime is equal to 9y, okay, what is the function that if I got its second derivatives, I will obtain the second derivative is equal to 9 times the function itself? So as a first guess, if you want to make first guess, one student will say y is equal to e exponential function e to the 3t, because the exponential function, when you got its derivatives, you will have the same function. Okay, so if I got the first derivative for this, first derivative of e to the 3t will be 3e to the 3t, and if you got again the second derivative for this will be 3 times 3, we got 9 e to the 3t. So this function is a solution for this differential equation. Okay, so this is the function itself. This is actually y here. Okay, this is the guess, your first guess. Y is equal to 9 times the second derivative is equal to 9 times the function itself. Okay, so this is one of the solution. Another student may say to me, there is another guess. I can also assume that y is equal to e, the exponential function, to the minus 3t. Is this a solution for my differential equation? Okay, so if you got the first derivative again here, or this, you got minus 3 e to the minus 3t, and if you got the second derivative again, minus 3 times minus 3 will give you 9 e to the minus 3t. Okay, so again this is your guess, this is your y. Okay, so again this is a solution. My second derivative is equal to 9 times the function itself. Okay, so in this case I have two solutions, two functions. This is e to the 3t, and this is e to the minus 3t. So the general solution for this, equation is equal to y is equal to the first function plus the second function. Okay, or any combination of them. Any combination of them, it means you can multiply this by any number, any constant number c1 and any constant number c2. We call this is the first solution y1, and this is the second y2, and the general solution is combination of both of them. In practice, you don't need every time to guess. Okay, you don't need to guess. So you may use directly what we call characteristic equation method. It's very simple here, so I will show you characteristic equation method. In characteristic equation method, you just write here, instead of this, lambda square as before minus 9 lambda to the power 0 is equal to 1. So this is the characteristic equation, and this is equal to 0. From the characteristic equation you will have two roots. Lambda will give you here plus or minus 3. Take this to the other side, take the square root. Means you have two roots. Lambda 1 is equal to 3, lambda 2 is equal to minus 3. Okay, so because these are real roots, real numbers, and they are different, 3 and minus 3 are not equal, So the solution is y is equal to two exponential functions. The first one is the first root to the power of the first root, function of time, e to the 3t, and the second is minus 3 to the power e to the minus 3t. Okay, so this is very simple, and you put here the constant c1 and c2. So writing the characteristic equation, you can solve this problem directly, in a simple way. The constants c1 and c2 can be found depending on the initial conditions. Usually you will have some initial conditions. For example, when the time was equal to 0, y was equal that much, and when the time was 0, the velocity or y prime was equal that much, some number. You plug these two conditions in this equation, and you can obtain the c1 and c2. Okay, so you can use the characteristic equation to find the solution. So if you look to the board, I write here the characteristic equation for this equation, and you want to find the roots. You will use the usual formula, minus b plus or minus square root of b squared minus 4ac divided by 2a to find the roots. And then there is three cases. Case number one, if the roots are not equal and real numbers, then the solution is just an exponential function. Two exponential functions. The first e to the lambda one, the first root times t, and the second root times t for the second function. And these are a constant number, can be found from initial conditions. The second case is if the roots are real numbers and they are equal, for example 7 and 7, minus 2 minus 2, okay, real numbers. So in this case you will have again exponential function here, okay, to the lambda t. For example, real number is 5t, e to the 5t, e to the 5t, okay, and because this function and this function are the same, okay, you should multiply the second function by t to be different, okay, because these functions are independent functions. This function now is not as same as this function, because two independent solutions. So you should multiply by t. This comes from theory. I will explain it later in another videos how this t comes, where this t comes from. Okay, but for now, if the roots are equal, you should multiply the second function by t. The last case, and it is very important in vibration applications, it's very important in especially free vibration. I will explain this later. If the roots are complex numbers, it means that if you have here the under the square root minus 3 or minus 5 or complex number I, so the roots, it has two parts, real part alpha and complex part beta I. So in this case the solution is a combination of two things: sinusoidal function, sinusoidal and cosine function, and the angle for this, or the angular frequency, is beta. So you use beta here for the sinusoidal and the cosine function, and the real part is the exponential function. So these sinusoidal and cosine function multiplied by an exponential function e to the power of alpha t, and of course there is two constants here. Okay, we will get some examples about that. I have three examples. The first one is y double prime minus y is equal to 0. So if you write this characteristic equation for this, it will be lambda squared minus 1 is equal to 0. From here you will obtain lambda is equal to, lambda squared is equal to plus 1. And if you take the roots, so lambda is equal to, lambda is equal to, lambda 1 is equal to minus 1, lambda 2 is equal to 1, plus or minus 1. So that because these are real numbers and not equal, so the solution is two exponential functions. The first one is the to the power of the first root minus 1 times t, and this is plus 1 times t. This is the two functions, and this is your solution. You just put here c1 and c2. Okay, the second one is if you see this equation and you write the characteristic equation, lambda squared minus 4, lambda plus 4 is equal to 0. If you solve this, you will have two roots. I can compose this to 2. This is 4, so it will be 2 and 2 here. Okay, and this is minus, so this is minus and this is minus. Minus 2 and minus 2 minus 4. Minus 2 times minus 2 is equal to plus 4. And this is your root. So in this case, equal to 0. In this case, you will have the roots. Lambda 1 is equal to lambda 2 is equal to 2. Okay, so these are equal roots. So in this case, I have two exponential functions again. Okay, the first one is to the power of the first root, 2t, and also because the roots are the same, this is also e to the 2t. And because this function and this function are similar, so you should multiply this by t to be different. And this comes from theory, and I will explain in later videos. Okay, and then you just put here C1 and C2. The last case, y double prime plus 2y prime plus 5y is equal to 0. And if you write the characteristic equation, you will need to use the formula of quadratic equation to find the roots. And if you do that, you will obtain that the roots are complex roots. You have some real part, which is minus 1, and some complex part to e, where e is the square root of minus 1, as you know. Okay, so we say that the solution is a combination of sine and cosine function multiplied by e function, and the power of the exponential function is the real part, which is minus 1, and the angle of the sine and cosine is the complex part. And I explain this usually in vibration problem, damped free vibration problems. If you have a damped free vibration problems, you will obtain a function like that, and it will stop. Okay, so if you connect the peaks here, you will obtain such length. Of course, it will stop at the end because there is a damping. So this function is your exponential function alpha t, and this function is the combination of sine beta t plus cosine plus sine plus cosine beta t. Okay, so this is what you have actually in that. Okay, thank you for watching, and please follow up the channel to see the new lectures. Thank you for watching.